Hi, today we're learning about frequency distributions, histograms, and stem and leaf plots. These are all parts of statistics. So I know I've got it when I can organize and present data as a frequency distribution, organize and present data as a histogram and frequency polygon, which is a line graph, and organize and present data as a stem and leaf plot, and identify deceptions in visual displays of data. So some key vocabulary: numerical information is data, statistics, which include descriptive and inferential statistics, a data item, a data value, how many times the data appears, frequency distribution, frequency, group frequency distribution, lower and upper class limits, class width, histogram, a frequency polygon, and a stem and leaf plot. So statistics, this is all included in this. It's methods of collecting, organizing, analyzing, and interpreting data, as well as drawing conclusions based on the data. Methodology is divided into two main areas: descriptive statistics, which is the collecting, organizing, summarizing, and presenting of data. And then there's inferential statistics, making generalizations about and drawing conclusions from the data collected. So descriptive is the actual collecting, organizing, summarizing. Inferential is making generalizations and conclusions from that data. A piece of data is called a data item. Collected data can be presented using a frequency distribution. Such a distribution consists of two columns. The data values are in one column, and the adjacent column is labeled frequency and indicates the number of times each value occurs. So, number one, construct frequency distribution of the data and age of maximum yearly growth for 35 boys. So this is a frequency distribution. All right, so age of maximum growth, it's got all their ages on the left: 10, 11, 12, 13, 14, 15, 16, 17, 18. And then it has the number of boys at that age. So like there's one 10-year-old boy. There are two boys that are 11. There's their frequency distribution for a boy's age of maximum yearly growth. So for example, there were 5 boys who grew the most at age 12. 7 of the boys grew the most at age 13. 9 boys grew the most at age 14, and so on. So what are some of the conclusions that you can draw from that example? Well, one of them is the maximum growth occurred for most subjects occurred between the age of 12 and 15. So you can see right here, between the ages of 12 and 15, that is where most of the boys grew. So there's only 3 that grew at ages 10 and 11, and 5 that grew 16 through 18. Most of them are growing between 12 and 15 years old. The number of boys who attain their maximum growth, yearly growth at a given age, increases until age 14, and after that it decreases. So see, what that's saying is that the numbers are going up and up and up and up, and then right here it starts going down. So you hit a maximum of 9 boys growing at age 14, and then the numbers are decreasing. What are some others that you see? That very few people have hit their maximum growth at age 10, and very few are still growing their maximum amount of growth at age 17 and 18. Now, this is not saying that only one of the boys grew at 18 years old. It just means that he didn't grow the most of his yearly growth at age 18. Okay, so here's something we're going to do. We're going to use the classes 40 to 49, 50 to 59, 60 to 69, 70 to 79, 80 to 89, and 90 to 99 to construct a group frequency distribution for the 40 test scores. Okay, so they are giving us 40 test scores, and they want us to put them in grouped data. So you can see what we've done. We've gone through and we've listed the different groups that they wanted us to group right here, 40 to 49 all the way to 90 to 99, and we made a tally. And then here's the important thing. You know that you should start off with 40 numbers. They gave you 40 numbers. So you want to make sure your tallies add up to 40 so that you're not missing any of the data. So after you did that, so once you get the tally marks, so we have 3 right here and 6 right here, and you can see I've actually written that as a number, 3 and 6 and so on. 40 is the sum of the frequencies, so it should be the number of the data items. You need to add that up. So now what inferences can we make about this? The class 40 to 49 has 40 as the lower class limit and 49 as the upper class limit. So these are the class limits. We were talking about that in vocabulary. The class width is 10 because you're going from 40 to 49, which is 10 numbers. It's sometimes helpful to vary the width of the first or last class to allow for items that fall above or below most of the data. And those would be the outliers. Okay, so here's one that you can do. Go ahead and pause. And this is what your answer should look like. So that would be your frequency data. All right, a histogram is a graph with bars that touch that can be used to visually display data. Okay, so and sometimes, or a lot of times, there will be a range of numbers right here, but it's a bar graph that touches. A frequency polygon is the line formed by connecting the dots in the midpoint of each bar. So you see there is a midpoint dot at the top of each one of these bars, and that is what the line is connecting. A stem and leaf plot is constructed by separating each data item into two parts. The stem consists of the tens digit, and the leaf consists of the units digit. So I'll show you what that means. All right, so you're going to use all of this data to construct a stem and leaf plot. So again, I'll show you what that looks like. These are the numbers again. So you're going to enter all the data in the first row. So for instance, this number would be 47, 57, 64, 63, 75, 82, 82, 93. That's how you do it. So the stem is all the numbers in the tens digit, and the leaves are all the one digits. So if I was making it for 82, if I was doing that, it would be 8, 2, and then 4, 7, 7, 7, 5. So I'm just kind of doing this, but you go in order of the stems to kind of organize a little bit better. And then when it's finished, it would look like that. So this would 47, 45, 43, and so on. Okay. This is an extra example we could do. We're not going to, but you can draw a frequency histogram and a frequency polygon from the frequency distribution that you've already been given. And in C, this gives you the ability to construct a stem and leaf plot from this information. So you want to look for your smallest number, which would be, let's see, in the 20s for sure, 27 maybe. And then your largest number, I see, is 70. So you're 72. So your stems would be 2, 4, 5, 6, 2, 3, 4, 5, 6, 7, and then you would list all the leaves out to the side. Okay, so let's go over some deceptions in visual displays of data. This is very, very important for the ACT. Also, you see this a lot on commercials. So graphs can be used to distort the underlying data. The graph on the left stretches the scale on the vertical axis to create an impression of rapidly increasing poverty rate. So you see this is called the break in the graph. Both of them have it. The difference, however, is this one is counting, you see 11.3%, then 11.7%. So they're counting by 0.4% for the y-axis. On this one, they're counting by 2%. So it's the same exact data, but since they're counting by different numbers on the axis, it makes the graph look completely different. Okay, the graph on the right compresses the scale on the vertical axis to create an impression of a slowly increasing poverty rate, like I said. Now, the table in the middle is the same information, but it's just posted instead of a graphic. And most people are visual, so they're going to be looking for something. So if they see a graph like this, they're going to go, oh my goodness, the poverty rate is increasing so much. But if they look at that graph, which has the same information but displayed differently, they're going to think, wow, we're doing okay. All right, so here's some things to watch for in visual displays of data. Is there a title that explains what's being displayed? So first, look for a title. Second, are numbers lined up with tick marks on the vertical axis that clearly indicate the scale? Has the scale been varied to create a more or less dramatic impression than shown by actual data? So see what they're actually trying. Don't just look at everything really quickly and form an opinion. You really need to look at those data marks that they're showing you. Do too many design and cosmetic effects draw attention from or distort the data? So they try to get your mind off of other things. They know that people are very visual, so they want to focus on that. Has the wrong impression been created about how the data are changing because equally spaced time intervals are not used on the horizontal axis? That is another thing that you can see. That, time is usually displayed along the x-axis because that would be the independent variable. So sometimes it's not equally spaced. Sometimes they're not counting by ones or twos or even fives or tens. Sometimes it might go 1, 2, 5, 10, 20, and so on. Are bar sizes scaled proportionately in terms of the data they represent? So sometimes they'll have a really small bar next to a really big bar, and it's the actual data is not that different if you look at the vertical labels. Is there a source that indicates where the data in the display comes from? Is it credible? Does the data come from an entire population or a small sample? Was a random sample used? And if so, are there possible differences between what is displayed in the graph and what is occurring in the entire population? Who is presenting the visual display, and do they have a special case to make for or against the trend shown by the graph? So some people are very biased. They want you to believe a certain thing, so they are going to show you what they want you to see, even if they have to skew the data. So I know I've got it when I can organize and present data as a frequency distribution, organize and present data as a histogram and frequency polygon, organize and present data as a stem and leaf plot, and identify deceptions and visual displays of data. Do you really understand? How are the frequencies and a frequency distribution related to the bars in a histogram? The frequencies are represented by the heights of the bars. So remember, we put that dot at the top of each bar and connected the line. That's how. Suppose a set of data consists of numbers between 20 and 45. Describe the stems and the leaves for this set of data. So your stems would be 2, 3, and 4, and the leaves would be the units digit or the ones digit of each data item. All right, I hope that helps. If you need me, let me know.